be useful. So, you know, when you see the extensions, you always start 626, 585, and then it's 7103 for me. Okay, so my office phone number over there, 626, you can write it down, 585 7103. But usually the most efficient way to get in touch with me is by email. Office hours, so my office is straight across the hall. I mean, you can look at the door into that main room. That over there is the Geoscience Study Center. And you're all welcome to use that if you want a nice place to study. There's some computers, there's lots of rocks and minerals and things like that because it's geoscience. But it's a nice place where you can study if you need to. So I just want to make sure you're aware of that. Room is available to all of you to use. Sure. And what's your last name?
Caratino.
Thank you. So if you go into that office, and if any of you want, there's some free giveaways in there too. So we have some binders that, if you're interested in a binder, talk to me afterwards. We got a lot of nice ones. But that's where the study center is. My office, if you go into that study center, it's all the way to the far right, E210G. So that's where I'll be. For sure, Tuesdays and Thursdays, basically all day. I'm here Tuesdays, Thursdays. Most of that time I'm in that office, E210G, but for sure, you can always find me on Tuesdays 1 to 2:30 p.m. and 5 to 6 p.m. And then on Thursdays 1 to 2:30 p.m. Okay, so that's the way office hours work, right? You don't have to make an appointment. I'll be there in that place at those times, so you can just show up. Okay, no problem. And if you want to meet outside of that, if you want to meet either in person or by Zoom, I'm open to that as well. So just email me if you would like to meet outside of those times. Okay. All right. So the textbook we have, it's a free textbook, so the price is right on that. Introduction to Oceanography. I have the link there. It's also you can get to it from the Canvas website. I have a PDF of this. You can just click on it from there, for example. And then I'll also put links to the reading. I didn't do this for the first module yet, but I'll put links to the reading and the modules for the Canvas course site. So the way the Canvas page is going to be organized is going to be by modules, and the modules are by date. Right, and so there's going to be an August 27th module that's going to have any lecture files that I might share, as well as a link to the reading and anything else of relevance, okay? So that's where you can kind of directly link to it if you don't want to type it in, but you might want to bookmark that book anyway. All right, and so, like I mentioned here, so on Canvas, that's where I post announcements. I posted the announcement about the time to make sure everyone had the right time. And as well as all the course files. Your grades will be updated on Canvas as well, so that's a way for you to keep track of where you are in the course at any time. Okay, so I do use Canvas pretty intensively in this course for those things. All right, so the student learning objectives, this is what we hope that you really come away from this course. That's what the student learning objectives are about. It's like, what if nothing else should the student take away from the course? And so the first one, you can see scientific method, using that in a basic way to analyze and evaluate oceanographic data. So we'll talk today about the scientific method. And then it mentions data that's presented in graphical, written, or map format. So in this course, at various times, we'll look at graphs, we'll analyze the graphs, we'll look at maps, nautical charts a little bit. and we'll analyze those as well. And then some rock and sediment samples as well. So you'll be able to make direct observations on those things and interpretations from that. Number 2, develop and communicate conceptual models of ocean systems that include biological, chemical, physical, and tectonic processes. So number 2 is basically getting across that the ocean is not compartmentalized. It has all these different components, and these components, you know, in the education system, we classify them into physics or chemistry or biology or whatever. But in reality, everything is all integrated. And so, you know, the biology, the little critters making their shells, those shells that they make out of calcium carbonate, that changes the chemistry of the ocean. Those shells rain down onto the sea floor, and that's influencing the geology, it's influencing the sediments. And so that's what number 2 is all about, is this idea that, you know, you're going to try to look at the ocean as this whole system where all these different parts kind of integrate with each other. And then number 3, formulate oceanographic research questions and hypotheses to evaluate solutions to complex real-world oceanographic problems. So you can see formulating research questions, that's part of the scientific method. So you're thinking about the ocean, thinking about the problems. What are some problems that exist in the ocean today? Trash. That's a big one, right? So much trash, right? A lot of pollution that seems to be accumulating. The rate of plastics coming in is far greater than plastics being removed, right? And so that's one of the big problems. Any other issues related to the ocean?
Warming waters.
Yeah, warming waters, exactly. And warming waters have a lot of impacts. They can impact the ability of the species to survive. They increase the intensity and frequency of hurricanes. They cause sea level to rise up, so along the coastline, and you know, in Miami, they have to keep dumping sand on the beaches, right? And guess what happens the second a hurricane comes? Removes all that sand. It's like another $1 million to refurbish that, right? So these are like kinds of issues that we as humans kind of have to deal with the ocean. And so that's what number 3 is about, thinking about those things and trying to figure out some possible solutions to those. All right, so moving down, class policies and information. So the work expected, the weekly work is reading before class, and the text it's pretty short chapters. So, and what you might want to do with the text, I always recommend this, skim that chapter, just like a quick reading before class, maybe spend a little more time at the beginning and the end, you know, intro and summary, right? And then skim. And then after class, you can go back and see what resonates, right? I think that's probably the most efficient. Participation and engagement during class. Including notes, completing homework, studying for exams, things like that. The homework, I've changed that, so that's going to be in-class assignments. So instead of homework, it'll be assignments that we do in the class session. Okay. All right. Attendance policy: you should attend all class sessions, arrive each day on time. And this is true for all your courses. So any student who misses 4 class sessions, the instructor is told to drop that student. And usually instructors will communicate with the student, but not always. So just know if it turns out that you're missing not just this class, any class, make sure to communicate with the instructor, because with 4 drops, you may be dropped. Now, if you know, worst comes to worst, and you know, you're halfway through the semester and you're like, I'm out, you make sure that you drop the course, because the you know, instructors may not always do that. So just make sure that you tie up those loose ends. Don't just assume that the instructor may drop, because it will drop because it can fall through the cracks. All right, so that's attendance. Assignments, so each Thursday, somewhere near the end of class, usually there will be an assignment that you do, and so you have to make sure to attend those classes to be able to do those assignments. Anyone else need a syllabus? What's your last name? All right, and so if you missed that, you can make up to 2 of these assignments the following week, just coming to office hours, but you do need to contact me within 24 hours of that missed class session to just make sure to email me, let me know what prevented you from coming to class, and then you could make that up. So that's the nature with the assignments. You can make up 2 assignments if you've got this reasoning. You contact me within 24 hours, and then you'll do it the following week. That's how that works. So academic honesty, so you're expected to write your own answers to question, any of like the in-class assignments and things like that. You can obviously discuss things with each other, but make sure whatever you write down is like processed through your brain and into your own words, right? Instead of just, your neighbor may have really nice writing, and sometimes it is kind of hard to get away if you've seen something written one way, to try to write it the same thing a different way, but that's what we have to do. Okay? So just make sure to do your own work through everything, and that includes like AI chatbots and things like that are not allowed for these assignments. All right, accommodations. If you need accommodations, make sure to contact DSP&S, and they will take care of everything else. Okay, so that's how you start that process. I've already received a couple of requests from them, so it looks like a few of you have already started this process. All right, any questions so far? No. All right, so next page, grading. You can see there's 3 components of the grade. First is those Thursday assignments, so there's 1 of these each week, due at the end of class that day. All of them are equally weighted. And then 40% of your grade is exams. And these a variety of formats, but usually dominated by short answer. You can make a note of that. It's usually the kinds of questions that I write is short answer questions where you have like a third of a page or something to write your answer. But they could include other formats, can and will. And so the exams are taking most of the material from lecture. Okay, so that's why it's good to make sure, like during lecture, you take good notes on it, because that's where most of the exam questions are going to be coming from. They also could come from the in-class assignments as well, kind of related things like that. They're not going to come from something from the text that is totally different from what we were talking about. Okay, that makes sense. So definitely use the text to kind of underscore what we're covering in class, and that'll help you study overall for the exam. And then if you happen to miss exam, again, just contact me within 24 hours and let me know what the emergency was. All right, and then 20% is classroom engagement. So I try to put the components of this here. So first, showing up on time, coming to class prepared, or usually skimmed over the reading, maintaining an engagement throughout the entire class session, avoiding distractions. Like it's easy, with the cell phone to be distracted. So if a student is, spending the whole class session down on the phone, then I'll make a note of that. So just try to make sure to avoid those kinds of distractions. If you have to look at something really quick, that's fine, but just don't do it too long. Being helpful during class activities. Making comments that move the discussion forward. Sometimes people can make comments just to make comments, right? Feel free to make whatever comment you want. I don't want to, but hopefully these comments are, instead of like veering off too much, to kind of like move things forward a little bit. I don't know if I explained that very well, but just feel free to make any comments. And then ask questions to clarify or probe deeper, and in general being inquisitive. So that's how that classroom engagement score is determined. Okay? And that's why being on time is important, because then you engage the whole class session. All right, grading scale is listed. It's the typical grading scale, right? Last day to drop without a W for all the classes that are normal 16-week classes, not condensed, that are starting today. These dates should be about the same. So last day to drop such a class without a W is September 8th, which is fairly soon. Last day to drop without, or with the W, I should say, where it's not going to impact your GPA or anything, but it will just, your transcript will show a W if you happen to drop a course after September 8th, but before November 15th. And then after November 15th, you cannot drop it. You're in it to win it at that point. Now, if there's something happens, some emergency happens near the end of the course, there's always a way through admissions and records to apply for an emergency change, right, of the withdrawal. But and they used to be more lenient during COVID times, but now they're back to being pretty strict. So there has to be you have to document whatever the emergency was that prevented you from finishing the class. And just so you know, there is always that option. But try to communicate with the instructor before it gets to that stage. All right, and so you can see the class schedule. What we're going to talk about, we're going to talk a lot about kind of geologic oceanography, essentially, and kind of how oceans form, how they evolve over time, how they change, where salts come into the ocean, how they get taken out, things like that. So that's going to be a lot of almost kind of a geology focus. And then the next segment, exam 1, is going to be on September 17th. And then the next segment's going to be a lot beginning chemistry and a little physics as well of the ocean. So how does the ocean interact with the atmosphere and vice versa, for example? And then why does water have all these magical properties that no other liquid does? So those are the kinds of things that we'll talk about then. Exam 2, you can see October 15th. Then we'll continue with physics, talking about waves of various sorts. Tides are a type of wave. Sound is a type of wave. It's like waves 1, waves 2, waves 3, waves 4. But they're divided into these different components. What is a wave, by the way? Since there's like 4 lectures on waves, how could we define a wave? If I'm telling you the tides are a wave, ocean waves that surfers ride are waves. Earthquakes produce waves. What was the other thing? Oh yeah, I think I got it. Sound, waves. So what do they all have in common? What is a wave? The wave kind of is like in a stadium. I don't like it too. What's happening when the wave where everyone stands up? What do they expend a little energy? Yeah. Oh, go ahead. Remind me your name. Sorry. Karina. Okay.
The movement, like repetitively.
Yeah. So there's some movement involved, right, with the wave, right? And so you mentioned repetitive. Is that right?
Because it's normally in the same sequence. It doesn't dip too far down or dip too far up. It's like.
Yeah. So if you were to trace out the path of a water molecule, Karina's right on with this. So as an ocean wave passes, and you feel this too if you ever swim out past the breakers, but you're kind of riding the waves as they go by, right? As the wave is coming, you get pulled towards the wave, right? You know that, especially if you ever tried to avoid a wave smashing on your head. So it pulls you towards it, right? As the wave comes, and then you ride up the wave, and then you go down the back of the wave, and then you get pulled to the next one. So you end up tracing, and water molecules do as well, this kind of circular path as the wave passes by. And so there's this disturbance that propagates, right? So as a wave passes one spot, you get this kind of circular motion, but then it moves over here. Right? Circular motion over here, and then over here. And so, in each of these individual frames, there's movement, but basically the molecules return to their original spot. So something is propagating, though. What is that thing that is propagating? What causes those water molecules to start, like in basic physics terms? What is really basic physics? Sorry. Yeah, well, it's forces, right? It's basically energy. Right? So even with sound, right? It starts with me creating this motion, right? So I use the chemical potential energy from my food that I ate a while ago, and I use that and transform that into this kinetic energy through my vocal cords, and that disturbs these air molecules, and that disturbs air molecules all the way along, and the air molecules kind of move back and forth in that repetitive way, all the way to the tiny little hairs on your ear. And so it's this propagation of energy. So that's what it is. So wave is a propagation of energy. Wherein so it's a propagation of energy wherein the molecules or atoms or whatever it is, they move and they return to their original spot as that wave passes by. Okay? So it's the same thing happening with light. That's electromagnetic radiation. That's a wave. Same thing with sound. Same thing with ocean waves. What's causing like big waves that surfers like to surf over here? What's inputting all that energy that makes such big waves, right? That push so well.
The sun? No?
It's related to the sun because this. Oh yeah. Maybe you could connect it.
I was gonna say wind.
Yeah, well, the sun creates the wind. Yeah, you're putting it together. So because you have different amounts of sunlight on the all around the Earth, you've got a big focus of sunlight around the equator, right? That's where most of the sunlight is hitting at a high angle, right? The equator's hot, right? And then it's cold over here. So when you get these temperature differences, what happens? Wherever it's cold, the air sinks. Wherever it's warm, the air rises, and in between the two, when air rises, it sucks in the cold air from around it. So these temperature differences caused by differential heating on the Earth's surface, where some parts of the Earth's surface get heated more than others, that's what causes this airflow. And ultimately, when you get storms being produced, big amounts of airflow, the storms blow and blow and blow on that ocean surface, and they put all their energy into the ocean surface, and that's what creates the waves that then propagate out. So it's storms caused by this, originally beginning with the sun producing wind, that makes all these big waves that we see. All right, so big energy makes big waves. That's another reason why the ocean is so awesome, right? What's the number one rule of the ocean when you're exploring around? Let's say you're beachcombing, you're looking at the flotsam and jetsam, as some old Navy terms, just debris on the shoreline. So you're exploring. What's the number one rule when you're out there doing that?
If the water recedes from the
Yeah, that's right. If there's a big recession of the water, what might that mean is coming? Anyone else know? I think you know. Yeah.
Wouldn't it be a tsunami?
Yeah, tsunami. Yeah. So that's one thing. If you ever see like the really quickly receding, don't go up to pick the floppy fish. Run the other way. So yeah, go ahead.
Have you been to Miami?
Yeah.
Okay, have you
Oh,
been to Key
it's
Biscayne?
26, 15.
If you go in the morning,
No, I haven't.
it's like, you can go 30, 40 feet and it's just flat and calm. Is that dangerous? Or is it
Yeah.
just normal?
No, that's normal. So in general, like we'll talk about this later. It's winds are produced by differential heating. So what happens during the daytime is the sun hits both the continent, the land, and it hits the ocean. When the sunlight hits the land, it causes the rocks and the soil and everything to heat up. Okay? And that's what the lizards will climb on that and snakes to get warm. Okay? So this is really warming up. The thing about water, one of its magical properties is it has high heat capacity. So water just absorbs heat. And so what happens on a hot summer day, you got the sun shining down on both of these, the ocean as well as the continent. The land heats up, the ocean stays nice and cool. And like I said, wherever you get hot air does what? Rises, like a hot air balloon, right? So hot air rises and that draws the cool ocean breeze in like that. So in the morning, before you've had this effect, before the sun is shown like this, the sea surface tends to be nice and calm. And so it's in the later afternoon, that's when it picks up. So if any of you ever think about like renting a boat or renting kayaks or things like that, if you want it nice and smooth for your experience, you want to go early. The earlier you go, the better. Now let's say you're renting a jet boat or something like that, and you wanna jump waves, then you would do it later in the afternoon. Okay. Oh, anyone know? So what was the number one rule of exploring the seashore? Never turn your back on the sea. Never, because there's rogue waves, right, that could potentially come. So we'll talk about how different waves from different storm centers, they combine with each other, and sometimes they can combine in an additive way, where you think you know how far the waves are extending, but you don't really know for sure what the full range could be. Right? Lots of videos, as you might imagine, on YouTube of people being surprised by giant waves. Some cases like washed out. So that's the number one rule. I hope you all have that. So whenever you're exploring, like always keep one eye looking out towards the ocean, just so you're aware of that. All right. So that was like a little bit of content I snuck in there. We'll delve into all of these concepts later on as well. It's just a little bit of a preview. And then so at the end of that segment between exam 2 and 3, we'll talk a little bit about navigation. That's where we'll look at some maps. And then the last segment of the course is really a lot about human interactions with the ocean. So we'll talk about resources that we get from the ocean, pollution, monitoring and remediation, things like that. Any questions about this? No? All right, very good. All right, so how would we define oceanography, do you think? What's a good definition of it? You tell me. Go ahead.
Like just the study of the ocean?
Yeah, well, that's a great start. Yeah, that's it. In a nutshell, study of the ocean. And you could add too, it's what particular kind of way are you studying it? I would say scientific study of the ocean. Big blue wet thing. That's before your time. Muppet Treasure Island. The captain called the ocean big blue wet thing. So it's a scientific study of the ocean. What aspects of the ocean are covered by oceanography? Remind me your name, sorry.
Patrick,
Patrick.
the sea floor.
Okay, good. You got sea floor. So I'll put aspects here. And what about the sea floor, for example? Not to put you on the spot.
The tecton, like the tecton.
Oh, like the
plates.
The plates. Okay, good. Type of. What tends to blanket the sea floor? Yeah, sediment. Yeah, so sediment. The sea floor is blanketed. And what type of sediment are you typically going to find kind of, especially when you go deeper? Is it going to be like really coarse, big pebbles? Or do you think it's going to be finer sediment, like really small, like silt and clay type stuff? So it's blanketed by what's called fine sediment. And when I use that term fine for sediment, it just means small sizes. So geologists will call sediment coarse if it's big, like boulders and sand, and they'll use fine if it's things like silt and clay. Clay is the finest of all. And you're familiar with clay. It's like really, really fine sediment. So that's what you have blanketing the seafloor. Is there anything living inside the seafloor? Oh yeah, all sorts of little critters. So you got critters like polychaetes. Polychaetes are a type of worm. They're number one in diversity and abundance in the seafloor all around the world. They're number one. Guess who's number two? Number two happens to be the type of animal who's number one on land in terms of diversity. What's the most diverse group of organisms on land?
Birds.
Even more than birds.
Insects. Yeah.
Mammals?
Birds are awesome though. Yeah, arthropods. Arthropods including insects. So arthropods include crustaceans, like crabs, shrimps, things like that. Little sandhoppers. Do you ever pick up some kelp on the beach and you see these little things hopping around? Those are arthropods. Little sea lice, things like that. Those are all arthropods. So these are the little dudes that live inside the sediment, for example. And they're you can use these in a number of ways because they will often, what species you have will tell you how much pollution is coming into that environment. So certain species, they're indicator species, they're more pollution tolerant, and others can't deal with any at all. So there's information about other aspects of the ocean that you can get from the biological. So this is biological, that's geological. In this course, because this is physical oceanography, we're going to be focusing on the geology, the physics, the chemistry, but because it's interdisciplinary, we'll also be talking about these folks as well a little bit. Yeah. All right, any other aspects of the study of the ocean?
Currents.
Currents, yeah, that's a big one.
Current events.
Oh yeah, and currents as well as current events. So here you have wind currents driving ocean currents. And you also have, remember, and this is true of any fluid, when you have fluids, which is like either a gas or liquids, any fluid where the stuff can flow. If you have some hot fluid and you have some cold fluid, they're always going to self-organize by density. The cold fluid is always going to go down, okay? And the warm fluid is always going to go up. And so this is true if you mix gases of different temperatures. It's true if you mix different liquids of different temperatures, okay? And so what ends up happening in the ocean at the poles where you've got very little sunlight, like direct, it's like it's half the year you don't even get any sunlight, and then the other half it's very low angle. That's where you end up having very, very cold water being produced at the surface. Colder even than the water that's below it. So what is that very cold water? It's getting colder and colder and colder down here. Where's it going to go? It starts at the surface, getting cold, 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 cold. It will go down. And then as it goes down, it runs along the sea floor. And then it pops up in a few places, bringing all its nutrients and things in certain regions. But that's another kind of current. That's called the deep ocean current. So winds drive the surface current, and it's temperature differences that drive the deep ocean currents. All right, so there's many other aspects of the ocean. This is just like a couple of them just to begin to get a little feel. You can see as you explore it, you can see the kind of the multidisciplinary nature of this, and how you'll often get a lot of the similar physical principles operating. Gravity, for example, is one of these motifs we'll keep coming back to. It really governs a lot. Why do deep ocean currents, why does that really cold, dense water go down? Because of gravity. So gravity is playing a role in that. And then that whole process of warm fluids rising, cool fluids sinking, that in general the term convection for that, that's another motif that we'll keep coming back to in this course. So you can see a little bit of that there. Let me go ahead and erase this. All right, so what is the importance, do you think, of studying the ocean? The importance of the ocean, and I put in parentheses, studying it. To us, yeah. Remind me your name, sorry.
It's Tia.
Tia, okay.
It's 70% of the.
Yeah. And because it's covering so much, it plays a big role, and an even bigger role in a lot of different things. Anyone think of any examples? Yeah.
Isn't it like if the tide stops, like the world stops?
Yeah, well, if the tides, yeah, and things would be very different if the tides stopped, and yeah, it's like that. We'll talk about that in the next class. That interesting interplay between the Earth, the Sun, and the Moon that produces the tides. Like so the Moon formed. Just spoiler alert here. About 4.4 billion years ago, shortly after the Earth formed, or the data indicates this. There was a big object about the third the size of the Earth that slammed into the Earth, shot up this debris. That debris coalesced to form the Moon. And that moon was initially like really, really close to the Earth.
Wasn't it like 4-hour days with how
Yeah.
fast this Earth was spinning?
Exactly, because the Earth was spinning really, really fast early on, but because of this moon, that moon has been slowing down the Earth, and so initially you'd have about 4-hour days, so you would be able to really see the sun tracking across the sky. So the moon used to be much, much closer. The Earth was spinning much, much more quickly. And then over time, because of the moon has slowed down the Earth, and at the same time, it's been drifting away a little bit.
And didn't that impact also tilt Earth onto its axis?
Yeah. So that's one thing you'll notice. The Earth is tilted 23.5 degrees right here from it's not straight up and down. And that's because of these big impacts. Originally, when the Earth formed, we'll talk about this in more detail next time, it was straight up, like this. All the other planets were too. And then boom, they got hit by this debris. We'll talk about why that is next time. And that's what caused the Earth to tilt like this. All right. So, with this big coverage over the Earth's surface, what does this mean in terms of like what we can get from the ocean or how we utilize the ocean?
Well, we need water to live.
Yeah, so it's a big source of water that, you know, with desalination you could potentially, yeah, so big. So because it's so much of it, it's a big source of, first of all, water. Resources. What did early peoples use the ocean a lot for? Like let's say when you're creating a bronze. Remember the Bronze Age, way back when? And so in order to produce bronze, you need copper and tin. And copper and tin were being produced in widely different areas. So copper was being produced in places like Spain, for example, and the tin was way up here, like in England and Scandinavia. So how were they able to ship the copper and tin? Via the ocean. So transportation, yeah.
Transportation, ocean navigation.
Well, what's that? Second thing you said?
Navigation.
Oh yeah, navigation. Yeah, so transportation, navigation, and with transportation, just as an FYI, this port that we have down here, you might have noticed there's a lot of big semi trucks on the freeways, right? Coming further and further over, right, to the fast lane, almost. And so that's because we have the #1 shipping container port in the Western Hemisphere.
Like us is in California.
Oh, you're talking about the Long Beach.
LA and Long Beach harbors, yep, combined, because they're right next to each other. Big part of our economy. Right? And in fact, there's funds now to kind of promote the blue economy, and you can potentially benefit from that. They're lining up jobs in ocean science. So some of the things, just so you know, that they're doing down at LA Harbor that all of you could potentially be a part of. They have aquaculture programs. So they're growing all these different kinds of seaweeds, fish, mollusks, little marine, like scallops and things like that. So they're all these startups are getting going over here at the harbor. And then also some carbon capture things that are being done by Caltech folks and UCLA folks. And so anyway, there's a big, we got this giant port, and this port is kind of being used for more research and kind of outreach types of things. So just wanted to put that out there now. It's also a big source of absorbing heat.
I was about to say the carbon cycle.
Yeah. Absorbing heat. And it absorbs heat in two ways. It directly absorbs heat and it takes in carbon. So it takes CO2 out of the atmosphere, for example. And that CO2 gets locked in the shells of little critters. Okay? So that CO2 actually goes into making that. So reducing atmospheric CO2. So some of what they're doing down at LA Harbor with this blue economy program is getting going is to try to capture carbon more from the ocean. What is it also a big source of this ocean? I mentioned aquaculture. Food.
Fishing.
Yeah, fishing, yeah. Fish and seafood, right? Food. For resources here, there's a variety of resources, right? There's mineral resources. This is in the news recently. You may have seen there's been a rush to try to extract these metal-rich nodules, in particular around this region here. Okay, but these nodules we'll talk about later, they're like an electric car battery in a rock. They've got everything, a lithium, nickel, copper. It's like all these metals all combined in these little resources. And so because of the fact that we're running out of these rare earth elements and other metals kind of on surface deposits, that's why people are now turning towards the ocean. Because there are these little metal balls that they could harvest them. So anyway, that's why that's been in the news more recently, because we need cell phones and electric cars and things like that. In order to power the batteries that are in these things, you need those kind of resources. Those are called, just so you know, polymetallic nodules. And that's just one example of the kind of metallic resource you get from the ocean, but that's a big one. That's big in the news.
By taking all those resources out, does that affect the ocean?
Yeah, exactly. And so there's a lot of concern by environmentalists. So the business folks who are in charge of these companies want to just go ahead and do it, right? And it's the researchers that are saying, now wait a second, it took like millions of years for those spheres to accumulate, and there's all these organisms that are living in the seafloor that you're going to disrupt. You're going to disrupt chemical cycles in the ocean. Yeah, exactly. And so there is concern about that. And so this is all playing out in real time for all of us.
What part is that called?
So
What
it's
part of the
happening.
ocean?
So this is the Clarion Clipperton Rift. I'll just write that down since you asked. That's one of the places where there's a lot of these, and so they want to start. That's called Clarion Clipperton Rift. And that word, what does rift mean? If a rift is formed between us.
It's going apart.
It's separating. Yeah, it's a separation. And so, do you see this? It looks like stitches, right? It's this long underwater mountain range. This is another spoiler alert. This is where the Earth's plates are pulling apart.
So it's a mid-ocean ridge.
It's a mid-ocean ridge. Yeah, and the thing about that mid-ocean ridge is as the plates pull apart, magma comes up from below that heats the water. Hot water, as it's passing through that seafloor rock, dissolves all these metals from the rock into the water. That hot water then comes out through, you might have seen these, they're called black smokers. They're underwater where it looks like black smoke that's coming out of these chimneys. Have you seen those underwater things? Anyway, that's all metals. So all along these rifts, you have metals that are coming out, and so that's why you tend to get a lot of these polymetallic nodules. That's the source of the metals. It's actually coming from these rifts. That's where the hot water enriched in metals is coming out, and the metals precipitate once they come out. All right. So these are just anything else that what about you folks? What do you use the ocean for?
Fun.
Fun. Yeah, right. That's another importance, right? It's fun. It's enjoyable to go to the beach. Recreation, right? All sorts of recreation. You can do whatever you want at the beach, right? Kids always love going to the beach. Everyone likes the beach. And so these are just some examples of the importance. There's more that we'll talk about as the course develops, but I just wanted to hopefully try to underscore that there is a lot of significance to studying the ocean from a human perspective. And also it's just kind of interesting too. All right, and so what about, we mentioned that this is the scientific study of the ocean, right? That's what oceanography is. So what exactly is meant by that? What do you think of when you hear like science or scientific method? What can we say about science, scientific method? You don't have to really define, you could define it if you want, or just say like something about it.
Hypotheses and trying to prove or disprove them.
Yeah, so it's kind of centered around testing hypotheses. Now, and what is a hypothesis? Yeah, it's like a guess, right? So a hypothesis.
Is a theory.
Educated, yeah.
Yeah, educated is good. Yeah, hypothesis is it's an educated guess as to the answer to a specific question, right? So that's why when you see the scientific method shown, they usually start with like a research question. Well, usually they start with something above the research question, because science is driven by like a curiosity, right? Like you want to know something. And so even before the research question, you gotta have some input, right? You can't just come up with ideas in a vacuum. So usually it starts with like observations. To give you an example, like I try to turn the light switch, the light won't turn on. My question is, why won't the light turn on? That's my research question in this case. So science can be done in any context. It's not just specific to certain topics. And so from that research question, you come up with, and there's going to be different hypotheses, right? There's hypothesis 1, hypothesis 2, right? You could come up with different possible answers to that question, right? So you're typically going to want to start with the hypothesis, sensible, that you think is most likely. That's why educated guess, that's good to put that educated. So the one you think is probably most likely based on your experience and knowledge, and it's easy to test. Right, so like turn on the light switch, light won't turn on. What might be a first thing to check?
The light bulb.
Light bulb, yeah, replace the light bulb, right? There you go. Yeah, so that would be one thing you would do. And if that doesn't work, then what might you want to do?
Check the power box.
Check the breaker box, right? And then after that, see if there's some.
Any electricity actually running.
Yeah, exactly. You can test the wiring in the house. So those are like 3 different hypotheses, right? For what's wrong. You go with the one you think is most likely based on experience and kind of easiest to test. And then you kind of go from there. All right, what else can we say about science?
Why and how things happen.
Yeah, it's a study of why and how things happen. It's trying to figure out how and why things happen, events happen. And so, and this is key, so you're really trying to figure out how and why. That's the point I want to make about the scientific process, is that it's a rational method. It's a rational, logical method, and its only goal is to search for truth. And it has to be a, what's the term lawyers use? Good faith effort, right? Right? So that's the thing about science, and this contrasts with, say, political science, right? Because with political science, you're pushing an agenda, you're trying to support something, right? That's not the way science properly is. So with science, there's only one goal, and that goal is to try and figure out what is true. Okay? And so science is only pure if you stay focused on that goal. And it may not be a truth that you like, but if you're doing science properly, you know, you have to go with what the data indicate. So it's a good faith search for truth. And there's a famous explorer we'll talk about a little bit later in the course, Captain Cook. You may have heard of him. But we'll talk about him later. But he explored for the British Empire, like much of the world's oceans, and he did very well. He had this kind of Quaker upbringing, and he took with him from this Quaker upbringing this quote. It's magna est veritas. So that's a Latin term that means truth is great. So a couple of other things I want to point out. It's like, if you're doing science right, you're going to be open-minded. So you should be open to new ideas. But you should also be a little bit skeptical. I've heard this phrase before, open-minded skepticism. So you should be both open-minded, but also have some skepticism.
So don't take everything on blind faith.
Exactly, right. So, and what's allowing you to, when you have all these new ideas, how do you figure out how to assess them? What are you looking at?
Evidence.
The evidence, yeah. You're focused on evidence. You focus on evidence for and against competing hypotheses. And so there's some questions that are kind of straightforward, like light bulb won't work, I changed it, it works now. Haha, done, right? So other things tend to be a little bit more complicated, especially when you start asking more complicated questions about the ocean. Like, for example, one of the great mysteries of the ocean is we have seen a lot more CO2 in the ocean. We have seen the oceans warming. but for some reason, the pH change that has been predicted hasn't shown up everywhere. So you expect with more CO2 in the ocean, you're going to get, we'll talk about this later, it's going to get more acidic. Okay, and in some places they have seen it become a little more acidic with more CO2, but in a lot of other places they haven't seen it yet, and no one yet knows what's going on. So there are some like big questions where we still don't know what's happening. And so for those, we always have to acknowledge, if you're doing science right, you need to acknowledge uncertainty. Acknowledge that you're not going to know the answer to something. So to give you an example of that, if you look at language, so you have like dogmatic type language. It is true, is a fact, definitely, no doubt, as opposed to scientific language, which uses terms like probably, possibly, most likely. So you can kind of indicate that there's some evidence for something or a little evidence, but it's in how you word it. And so you always want to acknowledge the uncertainty. And just give you an example, I watched a fair number of these crime documentaries. I don't know why, but it's interesting to see how often the district attorney in these cases where it looks like the person was probably innocent, the district attorney says, "I know for sure this person's guilty. He definitely is guilty." It's like, that's not the way that criminal law should be. That's not the way that a proper, even-handed, measured analysis of it would indicate. Because scientific method use exactly the same thing with criminal law. You have a research question, who committed the crime? You have these different hypotheses for different suspects, and for each of those suspects, you can kind of weigh the evidence for and against. You have like a little scale, right? And so you kind of weigh the evidence for and against, like suspect 1, suspect 2, maybe that's 4, against, right? And so this is how you should really be thinking about it. And you should always be thinking about like, who are the other possible suspects? And it seems like in some cases, the whole criminal justice system will just focus on one, right? One individual and feel that they got the win because this person's guilty, but it's not a win. In fact, you've compounded a crime if you put someone in jail for a crime they didn't. Now you committed a crime, basically, by not being scientific. And so that's why this is much better language because it more accurately represents our understanding of truth. That makes sense. Yeah.
It's also the same in civil law,
Oh,
depending
yeah?
on what it is. Because my mom just did a trial,
Mm.
and it was very much, we have all this evidence, but the opposing attorney's like, nope, you're still lying, we don't care. So,
Oh,
no, we still have this evidence, you can see that your client is guilty. It's like, no, we don't care.
The
sometimes
dogmatic thinking in response to it, yeah.
Because sometimes lawyers are just meant to be, we have to believe our client 100%, even if we know
right.
they are in the wrong
Yeah.
completely.
Yeah, no, I can see that. Yeah. So that's what in law too, since you can fall into that. But whenever you're really after truth, this is the method. So does that make sense? It's a method of thinking. You can apply it to anything, right? And you always need to understand. Think about something as being likely to be true or not likely. If you like numbers, you can say, I think it's 80% likely that, this happened or something like that, right? That's a way to think about the natural world, I would argue. All right, I'm gonna erase this here. Okay, let's see, got a little bit of time here. So I just want to go quickly to show a few slides to kind of emphasize some of these points really quickly. Let's see if I can wake this up. Sometimes it happens, sometimes it doesn't. Any questions at this point? And then I got something before you leave. Make sure you don't leave before I give this to you, because I'm going to try to learn a little bit something about you folks, and so you're going to make a little informational card, like a trading card, for yourself with some information. So I'll give that to you today before you leave, but then you can bring it next time to class and get the right password here. All right, so first thing I wanted to show you, this is where the Canvas site is up and running. There's hardly anything on it yet, but at least it is up and running. Just show you. So this is the information here. This is how the modules are going to be organized. I'll put a link to the reading down here a little bit later as well. And what I'll do, it'll be like sediments where the youngest is going to be on top. So I'll always, as we go through the semester, you'll see the most recent stuff near the top. And then I don't have anything entered in grades because there hasn't been anything, but as soon as you start turning stuff in on these Thursdays and for exams and things like that, you'll see that there. Feel free to use anything else like the discussions and whatnot. I just wanted to point that out, show that to you. That's the Canvas site. And so, oh yeah, so hey, are any of you in this course? Physical Oceanography Field Studies. All right, that's the spirit. Yeah. And so there's some space. So I wanted to advertise this. You can enroll now still. If you have any issues enrolling, let me know. This is meant to accompany this course.